Today we'll be showing how to set the VP or Velocity of Propagation with the MOHR CT100 series TDR. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment, and never connect to live equipment. When scanning a cable and saving a trace, the accuracy of the distance default measurement depends on the VP, or velocity of propagation, being accurate. This is the fraction of the speed of light that electricity travels in a cable. You can get this number from the manufacturer in the CT100B or HF's file function, or you can set the VP manually. I like to trust but verify, and we've just touched on the first two. They're valuable references and great starting points, but if you want the most accurate VP, you want to find it manually. After that, you can save it directly to your CT100B or HF unit for easy recall later. We're going to start with one of our test cables. Using a standard tape measure, we can see that our cable from end to end is exactly 3 feet or 36 inches. For this measurement, I'm going to subtract half of the last connector from this measurement. So now I'm measuring 35 3/4 inches. I'm now going to connect the cable to the TDR after shorting the cable to disperse any static, of course. Now press the orange Auto Fit Help button and select Auto Fit from the menu. This will make the whole cable I'm testing visible on the screen, and the cursors will be placed at the beginning and near the end of the cable. Notice the appearance of the end of the cable when I connect a shorting cap to it and how it changes. This is how you know you're at the end of the cable and it's not damaged somewhere in the middle. Using the scale and position knobs, I'm going to zoom in and position the second cursor at the end of the cable. Showing you what it looks like up close when I manipulate the end of the cable and add a short cap. Notice how the end of the cable changes when I add the short cap. Any component that you add to the end of the cable is going to add length to the cable. Again, this is how you know you're at the end of the cable. It's important to note that a TDR measures in time, the time it takes to get to the measurement and back. That's how we come up with the equation of distance over time equals velocity of propagation, or VP equals D over T. I'll select Adjust VP with the M function button, first using coarse, then the M function button to toggle to fine, and adjust the VP till the measurement shows the predetermined length of 35 3/4 inches. As I'm adjusting, notice that the time stays constant. You're not adjusting the length of the cable, you're adjusting the variable to make the equation match what has already been physically measured. Now we can see our VP of 0.04729 here, and it's rather close to the predetermined value in the TDR, just more exact for this brand of cable or even batch of cable. You can also save this VP reading to the TDR for later use. Now to put it into action by measuring another cable, try this shorter cable and see what it measures. Place the second cursor at the end of the new cable, and we can see our cable length of 35 inches right here. And it's based on the VP of 0.704729 that we determined here. And we can verify our physical measurement of 35 inches with our tape measure. And that's how you find and use velocity propagation for your measurement with the MOHR CT100 series TDR. For more information, like and subscribe to our YouTube channel, visit our website at mohrtm.com, give us a call or shoot us an email, and we'll see you next time.